Hey guys, in this video I am going to walk you through how to solve the 5 hardest maths questions in the 2022 Year 6 SATs. Let's get to it. Question 24. Here is an isosceles triangle inside a rectangle. Calculate the sizes of angles X and Y. So in bold we have isosceles triangle and we have rectangle not bolded. Okay, the reason why we have isosceles triangle in bold is because an isosceles triangle is a special type of triangle. An isosceles triangle is a triangle that has 2 sides the same and 2 angles the same. So we can see that this, just mark them, this side and this side are the same length. This angle and this angle will be the same size. Okay, so another thing we know about triangles is that they add up to 180 degrees. And as we know that this top bit is 30 degrees, we know that with these 2 angles they're going to add to 180. So if we were to subtract 180, okay, if we were to do 180 subtract 30, we would have 150. We know that the 2 angles at the bottom have to add to 150, and because it's an isosceles triangle, we know that those 2 angles will be equal, so we can simply divide 150 by 2 to find those angles. Now you might need to do that in the bus stop, or you might just know that 150 divided by 2 or 150 halved is 75. So both of those angles are going to be 75. X is going to be 75. And we know that because it was an isosceles triangle, and that gave us the clues. So the fact that this was an isosceles triangle is what led us to the answer X, because we are able to subtract 30 from 180 and then divide that equally by the 2 angles because we know they are the same. Now, if we know that X is 75 and this side is also 75, something else that we know is that a rectangle has 4 right angles. So in each corner they are right angles, including where X is and where Y is. So if I was to draw, that is a right angle. Now we know that the part of that right angle that is inside the triangle is 75 degrees. So we know that this missing part here is going to add to 75 to make 90, sorry, just said the answer. So 90 degrees, subtract the 75 that's inside the triangle, gives us the missing portion, which is 15 degrees. 15 degrees. Okay, so again we're using properties of shapes of what we know about rectangles to find the missing section. We know that a rectangle has 4 right angles. The corner of that triangle was right in that right angle, so we just had to subtract the angle that was inside the triangle from the angle that's outside the triangle. Question 25. The triangle is to be transformed on the grid as follows. First, translate the shape 7 units down, then reflect the resulting triangle in the y-axis. Draw the new triangle on the grid after each transformation. So we've got 2 transformations here. It's why it says to draw the new triangle on the grid after each transformation. The first one is a translation, and the second one is asking us to reflect the resulting triangle. Okay, so that means reflect the triangle that we have drawn after translating it. It's also asking us to reflect it in the y-axis, and for the translation we need to do that 7 units down. So the first thing we're going to do is we just take the first transformation. Translate the shape 7 units down. Now what I'm going to do is mark each coordinate, each vertices of the triangle. So I'm going to take this one first, and it says go 7 units down. I'm simply going to count 7 units down. So if we start here, we'll go 1, 2, 3, 4, 5, 6, 7. So we have 1, negative 2, 1, negative 2, and then I'm going to take this coordinate at 1, 1, and we need to move it 1, 2, 3, 4, 5, 6, 7. That is at 1, negative 6. And finally, this coordinate, this vertices, we're going to move it down 7 places. Now I do tend to plot each coordinate, each vertices, and plot them separately, because if you start to just sort of guess where it goes, you could leave room for error. So just mark each point, each corner on your triangle, each vertices, and then translate each one separately. So 1, 2, 3, 4, 5, 6, 7. So we're at 5, negative 3. So 5, negative 3. And then you can draw your triangle. Make sure with questions like this that you use a ruler. Examiners will be looking at these shapes on a computer screen, and they are able to zoom in to each point, and they'll have a measuring tool, and there'll be a certain margin of error. This is very hard for me to do on a computer screen compared to when you've got a pencil and a ruler. It needs to be quite accurate because they will zoom right in, and if they are slightly out, or if they're out too far, then it won't be counted. But you can see here, other than that line that's coming down, so if this was on paper, I'd say this bit here is not good enough, it needs to be straighter. You can see the shape looks the same, it's just moved, the whole shape's moved 7 units down. Now reflect the resulting triangle in the y-axis. So first of all, let's just have a look at the y-axis. The y-axis is this one that comes down. It's this one that comes down here. So that's going to be our mirror line, okay? So we're going to take each vertices again. So I am going to look at this vertices here, and it's going to reflect across the y-axis. That's my mirror line. So it's 1 away from the mirror line. It's going to go 1 the other side of the mirror line. So I can put my marker in at -1, -2. So again, I'm going to just plot my corners in, -1, -2. Next, I'm going to go to this vertices. This is 1, 2, 3, 4, 5 away from the mirror line. So 1, 2, 3, 4, 5. 5 away from the mirror line is -5, -3. You can also see that this first coordinate is -1, -2, and it was 1, -2. This last one I've just done was 5, -3. Now it's -5, -3. So the actual coordinates themselves are the same on the y-axis, but they are the opposite on the x-axis. So if it was a positive, it's now a negative. So by that theory, our last coordinate, this one here, is 1, -6. It will be -1, 6. And if we just check it, we're 1 away from the mirror line, 1 away from the mirror line, and we go beyond it 1, it's -1, -6. So if we plot that last point in, and then we can draw our triangle. Remember to draw it very accurately with a ruler. Okay, so again, my point at the bottom isn't perfect, to try and draw as accurately as you can when you're doing that on paper. So you can see, first I translated the shape 7 units down, and then that shape that we translated is the resulting triangle that was then reflected in the y-axis. So that means that the y-axis, the axis that's labelled y, the one that goes up, was my mirror line. I've reflected it across there, and we've drawn a new triangle after each transformation. Kim makes a cuboid model using straws. You can see we've got the height, length and width identified on the model. So let's look at the height. She uses straws that are 7.5 centimetres long for the height. She uses straws that are 11 centimetres long for the length. She uses straws that are 8.5 centimetres long for the width. What is the total length of all the straws in her model? So let's first of all have a little look at the amount of each of these dimensions. So if we look at the height, how many straws are used in our height? And we have 1, 2, 3, 4. So 4 straws are used for the height. For the length, we have 1, 2, 3, 4. And for our width, we have 1, 2, 3, 4. So each dimension has got 4 straws used, and we have the length of each of those straws. So we simply need to find 4 lots of 7.5, which is the same as 4 times 7.5, 4 lots of 11, and then 4 lots of 8.5. So I'm going to do the 4 times 11 first because that's the easiest. It's 44. Now for 4 times 7.5, I'm going to do 4 times 7 is 28, and 4 times a half is 2. Add 28 and 2, I have 30. And for 4 times 8.5, I'm going to do 4 times 8 is 32, and 4 times a half is 2, 32 and 2 is 34. Now I've got the totals of the length, width and height. What is the total length of all the straws? I simply need to add all those numbers up. So we are going to add our 30, 44 and 34. 4 plus 4 is 8. 3 plus 4 plus 3 is 10. Our answer is 108 centimetres. Question 20. This table shows how many people finished the New York Marathon in each of the first 4 decades it was held. So let's have a look at the table. We have New York Marathon as our title. On our left side, we have the decade. So we've got the first decade, second decade, third decade, fourth decade. And on our right, we have the total number of people who finished. So we have how many people finished in the first decade, how many people finished in the second decade, the third decade, and the fourth decade. The question is, what is the mean number of people who finished the marathon per decade? Round your answer to the nearest 100. Okay, so here we need to understand what mean means. So mean is an average, and we need to find the mean average of how many people finish per decade. You'll see here that the numbers increased. The first decade there was only 24,863. The fourth decade was 350,824. So finding the mean is basically adding it all up and then sharing it back out again. So we're getting an even number per decade. So to do that, we first need to add the 4 numbers up, and then we need to divide it by how many decades there are. So we're going to take each of these numbers and put them into an addition. So first of all, I've put all of the numbers onto the grid so we can do an addition. So let's first of all start by adding up our numbers. So I'm going to do this in a different colour. 3 plus 2 plus 4 is 9. 6 plus, I'm actually going to add the 6 and the 2 2s because that makes 10, and then add 3 is 13. And again, I always try and look to see if I can make 10. So I'm going to add the 9 with the carried 1, that's 10. The 2 8s make 16, plus the 4 makes 20, so that's 30 altogether. Four and 2 and 3 is 9. 2 and 7 is 9, plus 8 is 17, plus 5 is 22. 1 plus 2 plus 3 plus 2 is 8. So we have 81,939, and this needs to be shared out amongst the 4 decades. So that means we need to divide it by 4. So if we pop that into a bus stop, 819,039. And if we divide that by 4, put that in a bus stop. And we divide that by 4. 4 into 8 goes twice, 4 does not go into 1. So we do put a 0 at the top because it doesn't go into 1, and we carry the 1 over because we didn't use it. 4 into 19 goes 4 times. 4 4s are 16, that means there's a remainder of 3. 4 into 30 goes 7 times. 4 7s are 28, that means there's a remainder of 2. 4 into 23 goes 5 times. 5 times 4 is 20, that means there is a remainder of 3. And 4 into 39 goes 9 times, that is 36, so that means there is a remainder of 3. And with your remainder, you might write, if you've seen that there is a remainder of 3, how to interpret that remainder. Your remainder is always the numerator, and the number you're dividing by your divisor is always the denominator. So the answer to this would be 204,759 and 3/4. Or you may know how to divide with a decimal, where you would put a 0.0 in the bus stop and put your remainder next to it. So that would become 0.30, put your decimal point at the top as well. 4 into 30 goes 7 times with a remainder of 2. Put another 0, the remainder next to it. 4 into 20 goes 5. It's the same number, 204,759.75. Either way, they are both the same number. 0.75 and 3/4 are the same. Now it says to round your answer to the nearest 100. So actually you don't even really need your decimals. Once you've got the first part of your number, the rest of it isn't really that important, because we are looking at the digit that's in the 100 place, which is the 7. We are looking at the digit that comes after the 100, which is 5. And that tells us, because it's 5, that we need to round up. So the number that we've highlighted needs to go up. So it would be 204,000. The 7 needs to round up to 800. So we now need to divide 82,939 by 4. So 4 into 8 goes twice. 4 into 2 does not go, so we must put a 0 above because it doesn't go, and we haven't used the 2, so it carries over. 4 into 29 goes 7 times. 4 7s is 28, so there is 1 remaining. 4 into 10 goes twice. 4 2s are 8, there is 2 remaining. 4 into 23 goes 5 times. 5 4s are 20, there is 3 remaining, and 4 into 39 goes 9 times with a remainder of 3. Now you might want to interpret that remainder. That remainder could also be 3/4, or it could be 0.75, okay? But it actually doesn't matter for this answer. We're rounding it to the nearest 100. So if I was to write that number out again, 207,259. I'm just going to write remainder 3. I could put 0.75 or and 3/4. The reason we don't need to know is because if we're rounding to the nearest 100, we are looking at the digit in the hundreds place, which is the 2. The 2 is worth 100. And all we do is we look at the digit after that, which is 5, and that tells us that our 2 needs to round up. If it's 5 or higher, our 2 needs to round up. So we've got our number at the start, we've got 207,000, that's staying the same. It's the 200 that we know has got to round up to a 3, and then everything else becomes a 0. So our answer is 207,300. Question 21. These two rectangles are identical. the length of each rectangle is 3 times its width. And we have on our grid 2 rectangles. We've got a little bit labelled on the rectangles, but not everything labelled. And then we've got our X and Y axes, and we don't have any labels along our X or Y axes either. And the question is asking us, what is the coordinates of point P? So we are having to find out what these coordinates, what the coordinates are of this point here. Okay, we've got blank axes, but we do have 2 clues. We have this clue, we have this clue, and the other clue we've got is that the length of each rectangle is 3 times its width. So we're going to use all of these clues to find out what P is. Now, a problem like this can look a bit intimidating, but we've got enough clues. We just have to be patient, and it's almost like finding the a trail of breadcrumbs. Let's look at what we know, and then let's try and label as much as we can until we are led to finding point P. Now, the 2 rectangles are identical, so that's another thing that is important. So let's look at what we know. The first thing that we can compare is that the negative 2, 8, so let me just highlight it. This point of the rectangle we know is negative 2, 8. We could also find out what this point is, because it's going to have the same y-axis coordinate as this, because it's the same height. And it's going to have the same x-axis coordinate as this, because it's at the same point on the x-axis. So we could actually label this part of our rectangle. If I do my brackets, I know that the y-axis is going to be the same as this, it's 8. And I know that the x-axis is going to be the same as this at the bottom, it's 0. Okay, why is that important? Well, the reason it's important is it's now going to tell us what the width of this rectangle is. I can figure out what this distance is here. By looking at the difference between the x-axes. Remember, going left to right is the x-axis. If I look at negative 2 and 0, that's telling me how wide this rectangle is. So it's 2 wide, because it starts at negative 2 and it ends on 0. So it's 2 wide. Now, we're told the length of each rectangle is 3 times its width. That means if the width is 2, that means that my length is going to be 6. So I know, I can label this now. That my length is going to be 6. So from here to here is a distance of 6. Now that's just telling me the length of the rectangle. It's not telling me the distance from the top there, from 0, 8 to the bottom here, this little bit here. But what I can do is, if I look at the y-axis coordinate 8 and 7, I can see that between 8 and 1, that's a difference of 7. So if this rectangle is 6 long, that must mean that this part is 1. So it's halfway. So what I can actually figure out now as well is what height this P is at. If this is at 0, 1, then this bit here is going to be 0 because it's the same. sorry, 0 because it's the same on the y-axis, the x-axis, sorry, and it's going to be 2. So now I have enough information to figure out what this point is worth. I know that it's going to be 0 because it's the same as this point down here and this point up here. Now this point on the y-axis, we can figure out what that is because we know that this rectangle is 6 long. That helped us to figure out that this is 1, a space of 1. So that means we've got to go 1 up to find the y-axis coordinate. So if this is at 0, 1, then, and this rectangle, this width is 2, then this is 0, 3. And actually we didn't even need to know that bit. Just knowing that this is 0, 1 and knowing that that width is 2, we could figure out that that is 0, 3. So that point is 0, 3. So we now know with this P part, if I do my brackets, we know it's going to have the same y-axis as the bit we've just discovered. So that's 3. And the x-axis bit is going to be 6 added on to this 0, 1. So if I started at my 0, 1 and I went along, I know that that's gone 6. I know that the width, the length of my rectangle is 6. I know that the y-axis coordinate is going to be the same. It's going to be 1, but my x-axis coordinate is travelled 6. So it was 0 and I'm adding on 6, so it's 6, 6, 1. So if that is at 6, then P is also going to be at 6 because it shares the coordinate, the x coordinate of the point below it. So we finally have our coordinates of point P. We had to go all around the rectangle to get there. And there were some bits we didn't need to do. I didn't need to find out that that was a space of 1 because actually just knowing that this bottom bit is 0, 1 is enough to know that that is 0, 3 once we found out that the width of a rectangle is 2. But I know for definite that I found the lengths and the widths of each part of the rectangle, and it led me to point P. So we can write in our final answer in the coordinate box, and make sure that if you are labelling the rectangle like I did and finding lots of different coordinates, that when you write the answer, you write the correct coordinates in your box. You don't accidentally write one of the other coordinates you found. So point P is 6, 3.
If you're looking for some effective revision to help you with your maths SATs, then check out the Pocket Private Tutor Shop. I have SATs ebooks and I have revision courses. The SATs ebooks cover every single thing from the Year 6 national curriculum, so you can be sure that nothing will appear in the paper that you haven't learned. Each ebook comes with a video which you can watch on a laptop, on a tablet, on your phone. You can even cast it to your smart TV if you want to watch it big. I have worksheets to help you practice the skill, and included are past SATs question examples. That means when you're learning a new math skill, I also include how that has looked in an actual SATs paper before. I also have some revision courses, I have practice arithmetic tests, I have loads of stuff that's going to help you to absolutely smash your SATs. So check out the Pocket Private Tutor Shop and download the course that's going to help you now.